Right then, on to the nastier questions. Now, the thing worth saying here is that if you've got everything right up to this point, it doesn't really matter how nasty these are, because you're already maxed out your grade. You're already guaranteed that C. Okay, so Miriam is planning a holiday in Pakistan. And Miriam went to an exchange bureau to get some Pakistani rupees for her holiday. She exchanged £540 for 8,500 Pakistan rupees. Complete the statement below, giving your answers correct at 2 decimal places. So there's going to be a mark for doing that bit there. So I know that £450 buys me that. So in order to work out what £1 would buy me, I've got to do the opposite of multiplying. I've got to divide. So I'm going to do 85,000 divided by 540. Which is that. Okay, so 157 point. Then we want 2 decimal places. So the 2 decimal places is 40, but you need to look at the next digit along to see if it's 5 or more, because if it is, it rounds up to the next one, which is 41. And because that is a 7, that's what we get. So £1 buys 157.41 Pakistani rupees. We're there on to time. Don't like time. Something that is quite difficult because you can't really use a calculator to deal with it. Miriam knows that when it is 1 PM in London, it is 6 PM local time in Karachi. Miriam is booked onto a flight leaving London on Tuesday at 13:50, so that's 10 to 2 in the afternoon. The flight time is 7 hours 51 minutes. On which day and on what local time should Miriam land in Karachi? Okay, so the easiest way to do this, I think, is to first of all work out, as if we were in Karachi, what time she'd be leaving London. So the time difference is 5 hours. If it's 1 o'clock in the afternoon in London, it's 6 PM in Karachi, so it's plus 5 hours. So when she takes off, the time in Karachi will be instead of 13:50, it'll be 5 hours on to that, so that'll be 18:50. So in Karachi, she's not leaving. It's already 10 to 7 in the evening when she sets off. Now we're just going to add the flight time of 7 hours 51 onto that, and this you cannot do on your calculator. Okay, so it's a fingers and thumbs thing as far as I'm concerned. That's 10 to 7, 10 to 8, 10 to 9, 10 to 10, 10 to 11, 10 to 12 is 5 hours, 10 to 1, 10 to 2. So the 7 hours is going to take her to 10 to 2 in the morning, which is 01:50, and then you've got to add on the 51 minutes. So add 51 minutes onto that. Well, if you added 60 minutes onto that, it would be 10 to 2. So then you take 9 minutes off and you will get to 41 minutes to. So that's going to be 02:41. So it's the following day. So it's not going to be Tuesday anymore, it's going to be Wednesday. And the landing time is 2:41 or 2:41 a.m. if you're not using 24-hour clock. So that's nasty because, like I said, you cannot use a calculator to work with time, or you can't easily use a calculator to work with time. Right, so marks for that question then. 14A is 1 mark for the division, 1 mark for getting a decimal answer, and 1 mark for getting it down to 2 decimal places. And then for the second part, we've got 1 mark for adding the 5 hours, then 1 mark for adding the 7 hours 51, 1 mark for Wednesday, and 1 mark for 2:41. So even if you just took a guess at Wednesday there, you're going to get a mark. If you didn't do anything else. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the page. Oh, Miriam's still flying. Oh, there's more. So Miriam's flight actually arrived 7 hours 45 minutes after departure. The aeroplane flying speed between London and Karachi was 434 knots. Given that 1 knot is 1.85 kilometers per hour, calculate the flying distance between London and Karachi, giving your answer in kilometers. So there's a few different steps that we need to go through to actually answer this. Again, this is a horrible question. First of all, you need to remember how speed, distance and time are linked. Now we rely on science to do this with you more often than not. Speed is distance over time, and they like to do that in science in a little triangle there. We want to find distance, so the speed and the time are on the same part of the triangle, the same level, so they're joined by times. So the distance is the speed times the time. So initially the speed is in knots, and the time, and this is where you have to be so careful, because the temptation to write 7.45 is strong, and it's not 0.45 because this is minutes, so it's out of 60. So if you just think in fractions, 45 minutes is 3/4 of an hour. It comes naturally to you to make that conversion, but you just want to write down 7.45. What you've got to write down is 7.75. So 434 times 7.75 gives you 3363.5. But you've got to turn your knots into kilometer per hour. So 1 knot is 1.85. We've got 434 of them. So we've now got to turn that multiplied by 1.85 to turn it into kilometers. So we've got 3363.5 times 1.85, 6222, and we're giving our answer in kilometers. Over that distance, we're not really going to worry about the 475 meters as well, so you could leave it at 6222, or you could add on 0.475. It wouldn't make any difference to the answers there. So that's a horrible question. So you got 1 mark if you have put 745, 2 marks for the correct method and turning that in, 1 mark for getting the 3363.5, 1 mark for getting the 622 at the end. That adds up to 4, and there are 5 marks. I've missed one out, hang on. There's 1 mark for multiplying the conversion, changing knots into kilometres. So there's the 3. Nasty question again. Question 15. Across the world, temperatures are measured using different units. All the unit scales are uniform. That means they all go up the same amount. Approximate conversions are often used to give a reading in more than one unit in scientific reports. Use the information below to complete the tables. Okay, so this is quite clearly going up in tens. So that's easy. What's this side going up in? So if we do 86, take away 68, we get 18. So that's going up in 18s. Check the next one is. So plus 18 plus 86 is 104. So they're going up in 18s. So this missing one is going to be 104 plus 18 is 122. What's happening this time? Well, it's actually going down. Okay, this is going up in hundreds, that side, and this side of the scale is going, if we just check here, we got 226.85, take 126.85, that is going in hundreds as well. So that's going down in hundreds that way. 126.85 take away 100 is that. That's that. So what I'm going to do now is take 100 off that, which is going to be minus 173.15, and then take 100 off that, which is going to be minus 273.15. So the marks for that part, for 15A, 1 mark for the 122, and for 15B, 1 mark for the negative 173, 1 mark for the negative 273. Total for the page 5, 8. And then for this one, we need to use the information here to fill those in. So to go from Kelvin to centigrade, 340 is going to be, this is going up in hundreds and hundreds, so 40 extra that way is going to be 40 extra that way. So the degrees centigrade one, Celsius, will be 26.85 add 40, which is 66.85. So that's that one. Then to take that and turn it into Fahrenheit, we've got to use this scale, and 66.85 is going to be 6.85 on there, but this doesn't jump by the same amount. 1 unit jump in there is the same as 1 unit jump in there, or 10 units jump in there will be 10 units jump in here. But for this one, it's different. For each degree that this moves, for each 10 degrees this moves, that moves 18. So 1 degree is going to be moving 1.8. Okay, so to turn degrees Celsius into degrees Fahrenheit, we've got 10 degrees Celsius is 18 Fahrenheit. So 1 degree Celsius is going to be 18 divided by 10, which is 1.8 degree Fahrenheit. Now I need to go up from 60, I've got to go up another 6.85. So 6.85 degrees C is going to be 6.85 times 1.8. Every bit of that is going up by 1.8 of the other. So I got 6.85 times 1.8 equals an additional 12.33 degrees F on 60. So it's going to be 140 plus that. $140 for the 60, and then another 12.3 for the extra 6.85. So that's going to be 12.33 plus 140, sorry, calculate off the screen, 152.33. Another nasty question. So what do we get for that mark wise? 1 mark for what are we doing? So there's 2 marks for the 66.85. So for doing that. 1 mark for the method of using the right table, which is this bottom table, and 1 mark for the answer, and then 1 mark for any answer there which is between 140 and 150. Then 1 mark for this method of working out the 1.8 degrees and working out the extra 12. Horrible question. Another question that's really there for the overlap with higher tier. Congruent is a word that means identical. Okay, so it's just something you need to know. Congruent means identical. So I'm looking for a two triangles that are identical to each other. Here's one. AED is identical to BEC. Doesn't matter what order you write those letters in, it's just showing it, a triangle. Then we've got another identical triangle there, which is exactly the same as that. So AEB is congruent, is identical to DEC. And then we've got these right angle triangles which are identical too. So we've got ADC, which is identical to ABC. 1 mark for each pair. Total for the page, 1, 2, 3, 4, 5, 6, 7, 8. And then the very final question. A factory production line packs buttons into bags. There are exactly 80 buttons packed into each bag. There's a mixture of different coloured buttons in each bag. A total of 600 bags of buttons were packed in a day. The first 100 bags were checked, and it was found that a total of 1,200 red buttons had been used. In the 600 bags of buttons, it was found that the relative frequency of red buttons packed was 40%. Calculate the relative frequency of red buttons packed in the final 500 bags. Okay, so let's try and unpick this question. First of all, there are 600 bags packed in a day, and in those 600 bags there are 80 buttons. So 600 bags times 80 buttons is 48,000 buttons altogether. And this is telling us that 40% of those were red. So 40%, 0.40, pence in pounds, times 48,000 is 19,200 red buttons altogether. Now in the first 100 bags, 1,200 buttons appeared. So in the last 500 bags, there were 19,200, less the ones that came up in the first 100. So 19,200 less 1,200, 18,000 red buttons in the final bag. In the final 500 bags. So in those final 500 bags, there were 500 lots of 80, so in final 500 bags, we're going to have 500 times 80 buttons. $40,000. So there's 40,000 buttons altogether, 18,000 of which were red. So the proportion which were red would be 18,000 out of the 40,000 buttons. So 18,000 red buttons out of 40,000 buttons altogether, times by 100 to give us it as a percentage. So we're going to do fraction button, 18,000 out of 40,000 times 100 times 100, I just times by 10, so times by 10 again, 45%. Another nasty question, but that's the last question on the paper. It's not going to be easy because it's overlapping with a higher tier. That's really pushing the high end of a grade C. So to mark that one, you're going to have 1 mark for seeing the 18,000. 1 mark for working out how many buttons there were all together, and a mark for working out how many of them were red. So 1 mark for the 600 times 80, 1 mark for working out 40% of it, 1 mark for working out how many red buttons there were in that final 500, and then 2 marks here for the process of 40,000 buttons altogether, and that as a sum, and then 1 mark for turning it into a percentage. So total for that is 7 marks. So that's a really tough last few questions on that paper, which is probably why when we go back to it and we look at those grade boundaries, the grade boundaries for a grade C were pretty low that year. Not many foundation year candidates would have been getting much on those last couple of questions.